Okay, so we have moved on and we are going to start talking about slope now. So we're on our objective B. So we're going to work on how to find slopes and a little more information about slopes. Once again, this is an equation that you've probably seen before, but the slope of a line, it really is telling us how steep a line is. So you've always heard of this rise over run. What we're looking at is a vertical change over a horizontal change. So this change here is my rise, because this is where my graph going from left to right rises or falls. And then we call this the run. But a rise, like I said, that's our vertical change. So we're either going up or we're going down. And then run is always going left to right. And that is our horizontal change. So what we're doing is we're looking at how much does the size of the change from one point to another point. So we have 0.1 and we have 0.2. And what we're doing is we're basically making a ratio of how the vertical changes according to the horizontal changes. So one way that we do this is, like I said, we talked about rise over run. You've seen that. Vertical change over horizontal change. We called it a change in Y over a change in X. You've also probably seen this before. So this triangle is also meaning a change. So like I said, as just a replacement for change is that triangle. But probably the best way to do slopes, so you're less likely to mess it up, is one of these formulas. So when you look for slope, so we call it M. And if you remember, y equals mx plus b, we said M is slope. So that's why we're calling it M, to go back to that slope-intercept form. Sorry about that. Normally when I make any recording, either somebody knocks on a door or calls me. Anyways, as I was saying, the best way to find your slope is really to use one of these equations, because I find a lot of times without the equation, some people are fine, but without the equation, there's a tendency to either you get a negative slope and you meant to have a positive slope, or vice versa, or sometimes you make a mistake and you put your horizontal change on top instead of on bottom. But it's basically you're going to have these 2 points. So like 0.1, we're going to label that as being an ordered pair that is going to be x1, y1. And then your 0.2 would be an ordered pair that is x2, y2. So what we want to make sure, as you see here, that when I put my points in here, that we're keeping the vertical change and the horizontal change comparable to each other. So we want to make sure that if I put y2 first, then x2 has to be first on the bottom. But if I put y1 first on top, then we have to make sure that x1 is first on the bottom, because it makes sure that we're keeping this in the correct direction. Because like this run is this change in this direction. So it's this change between x2 and y1. So we want to make sure that the other change of the y2, y1 reflects it as well. All right, so this is just continuing. Like I said, just a more visual version of this. So I realize now that maybe green and red weren't the best colors to pick. But like I said, you're thinking of doing this as blocks together. So you want to make sure that your twos are together. Y is always on top. And then your ones are together. Make sure Y is on top. Or if you do it the other way, if you put your ones first, you could put your Y second. That doesn't matter. What matters is that you keep those points paired like that. So you keep your twos together, you keep your ones together. Because that is going to guarantee that you don't end up with the wrong sign on your slope. So you don't end up with a positive when you meant to have a negative, or vice versa. So we want to find a slope of this line, of a line that's going to pass through the points 4, 3, and 7, 15. So it doesn't matter which ones are your x1, y1, x2, y2. I just usually just do an order. So this came first, so this is going to be my x1. y1. This will be my x2, y2. Then we said slope. There's two ways we can do it. We'll do both formulas here, but I can do y2 minus y1 on top, x2 minus x1 on bottom. Or like I said, the alternate way of doing it is that it would have been this way instead. You would have had y1, y2 minus y2, and you would have had x1 minus, sorry, x2. Like I said, we have our points labeled, so we know where to go. So my y2 is going to be the 15. My y1 is going to be the 3. So we're going to have 15 minus 3. Then x2 was the 7. And then x1 is the 4. So you're going to have 12 on top, 3 on the bottom. Your slope is 4. If we use the other version of the equation, so y1 is 3 minus my y2, which was the 15, my x1, 4 minus the x2, which is the 7. So the only thing that changes here is that you have negative 12 on top, negative 3 on bottom. Still that negative cancels out and you get a slope of 4. Okay, so your number 4 problem here is you are going to find the slope of a line passing through these points here. So take a minute. If you need to, go back and rewatch what we just did. But take a minute here to go through this and see that you can do A and B. And then once you have tried that, come back and we will complete it with this video. All right, so hopefully I had time to work on these, or you took the time to work on these. So I'm really just going to stick with just one formula, because as we've seen, it doesn't matter which I use, I get the same answer. This tends to be the more generic one that everyone uses. But like I said, just label your points. It doesn't matter which is which. X1, Y1, X2, Y2. So we said that Y2 is going to be a negative 14. And then we said that Y1 is going to be 7. So we're going to minus a 7. X2 was going to be 4 minus X1, which is a negative 3. So we are going to subtract a negative. So on top, negative 14 minus 7. So if you take out the negatives, 14 plus 7, so we get 21. On the bottom, that is going to be really 4 plus 3. So negative 21 divided by 7, negative 3. All right, for B here, we said, oops, just trying to write that slope intercept form there. M is going to be y1 minus, or sorry, y2 minus y1, x2 minus x1. So like I said, it doesn't matter which points are which. I could decide that this is going to be my 2's. Just all it matters is that x is first, and that these could be my 1's. It really doesn't make a difference. It's just like I said, as long as the x's are with the x's and the y's are the y's, you just make sure one point's just 2's and one point's are just the 1's. But in this case, I'm going to have y2 is negative 2, y1 is 0. So sometimes you have zeros, that's fine. Then we're going to have x2, we said was going to be 2, and then x1 was going to be 5. And we're going to get a negative 2 over negative 3. And this one's just going to be a slope of 2/3. So sometimes your slopes aren't going to be nice integers. Sometimes you're going to get fractions. Or just to point out this one little thing here, just once again, notice. Oops, sorry, it was not giving me my tool. Try one more time. There we go. Those points stay together. So 2, negative 2, they stay together here. It's just the negative 2's on top. So sometimes people just remember this formula just by stacking points like this. these points go together. Therefore, those points go together. That's really the most important thing. Like I said, and just make sure your Y's are on top.